Okay, Mandy and Addison are practicing for their softball tournament. Mandy pitches Addison the ball. Addison hits the ball from 3 feet off the ground with an initial velocity of 90 feet per second. What type of function would best describe the height of the softball is as a function of seconds? That's a little wordy, but you know my question. Since we're talking about velocity and something going up and coming down, that should remind you that this is going to be quadratic. Okie doke. So we have an A, okay, we're going to have a B, and we're going to have a C. So our A is acceleration, our B is velocity, and our C is our initial height. So because we're talking about feet, we're going to use -16. Our velocity is 90 feet per second squared, and then our C value, it's at 3. So when we put this all together, so the height of the ball, depending on how many seconds it's in the air, so here is our model. And we could figure out the maximum height by -b over 2a, and then plugging that into our function. So our vertex will tell us our maximum height and the amount of seconds it takes. We know our initial value, our y-intercept is 3. If we wanted to know the roots, we could use our quadratic formula to see how long it's going to take the ball to reach the ground. So what is the maximum height? So let's see if I can remember the equation. -16 x squared plus 90x plus 3. So the maximum height, -b, so our x value for our vertex is -90 over, so it's -b over 2a. And so we're going to get approximately almost 3, but not quite. So that gives me, we're going to say, I'm going to just round to the 10th. If you rounded 2.8125, that's more precise, but I'm just going to round here. Now we're going to plug that into our equation. So I have 2.8 and I'm going to square it, and then we're going to say times -16. And then 90 times 2.8 plus 3. So I got 129.56. We can say 0.6. So the maximum height is going to be 129.6 feet. How long does it take? Almost 3 seconds. How many seconds will it take the ball to land? So we are going to use quadratic formula. So -b plus or minus b squared minus 4 times a times c over 2 times my a value. So before you pick up the calculator, let's simplify inside. So 90 squared, that's going to be 8100. Then you're going to decide what your sign's going to be here before you do anything. So a negative times a negative is a positive. So I have 16 times 4 times 3 gives me 192. And then I have -32 on the bottom. So let's go ahead and clear and make our radicand one value. 8100 plus 192 is 8292 over -32. So because the ball started 3 feet in the air, it did not start on the ground, we will have a negative root, which will be irrelevant. So we're going to have, here is going to be one root and the other root. So this gives me a negative 0.03, so that's irrelevant. And then let's see what this one gives us. This gives about 3.126, I'm just going to say 1 second. So that's how long it takes for Mandy's ball to hit the ground. Okay, Parker is opening a tutoring business. He charges his clients $30 initial fee and $40 each hour of tutoring. What type of function would best describe? This is going to be linear because you have a constant rate of change. For every hour it goes up 40 and an initial fee. So very simple. Linear functions are very simple, very dull and a little bit boring, but oh well. So there is our model. Jackson and Kanan are starring in the Broadway musical Phantom of the Opera. In their first production, there were 800 attendees. For the next several shows, they had a growth rate of 12%. For each show, what type of function will best describe the number of people attending the musical? So it is exponential because we are growing at a rate, a percentage. So our A value is the initial amount of people. And then our B value is, it's a growth. So the rate is 0.12, okay, but the growth factor is 100% plus the 12% growth. So that's our B value. Okay, so let's see what X represents though. So in their first production, so production number 1, they have 800 attendees. It's not grown yet. So 0,800. So this X value represents the show plus 1. Okay, so in our first show, 0 is representing the productions after the first show, when the growth started. Okay, so remember, anything to the 0 is 1. So that's how we get our initial 800. So my X is going to represent the show after the first original production. So when I put a 1 here, it's going to represent actually show 2. Does that make sense? Hopefully. How many people attended the 6th show? Okay. So here's our function. So remember, our first show is 0. So our first show X is 0 because that gives us our initial 800. So our second show X is going to be 1. Our third show X is going to be 2. Our fourth show X is 3. Okay, so whatever show it is, minus 1 is what your X value is. Okay, so let's do that. So on our 6th show, okay, this is kind of like a geometric sequence. So we're going to plug that into our calculadora. 800 times 1.12 caret raised to the 5th. That gives us, and of course we can't have a partial of a person. So this is about what I got. 87 and a few other decimals. So let's just round it to this many people. So we had 1,410 folks show up at this amazing musical Phantom of the Algebra.